PJON is a tool created to simplify communication between devices and network engineering. Choose the medium you prefer, build your own network of devices, and make it work with few lines of code. There are 6 strategies available to communicate data with PJON on various media. Software bitbank. Software bitbank is the default data link layer strategy used by PJON template object. This implementation is based on micros and delay microseconds. It makes no use of dedicated timers or interrupt-driven strategies to handle communication. It is designed to have a small memory footprint and to be extremely resilient to interference and timing inaccuracies. Thanks to the use of a dedicated digital write-fast library, can be achieved fast and reliable cross-architecture communication through 1 or 2 pins. Oversampling. Oversampling is used to have high resilience in high interference scenarios, like using an ASK or FSK chip-ready transceivers in an urban environment. It is tested effectively with many versions of the ASK or FSK 315 433 MHz modules available on the market with up to 5 km range, but it works nominally also through wires and a human body. Ethernet TCP. With the Ethernet TCP PJON strategy, multiple devices with Ethernet ports can use PJON to communicate with each other on a LAN, WAN, or across the Internet. LocalUDP. With the LocalUDP PJON strategy, multiple devices with Ethernet ports can use PJON to communicate with each other on a local subnet, wired or over Wi-Fi or both. Through serial. With through serial data link layer strategy, PJON can run through a software emulated or hardware serial port. Thanks to this choice, it is possible the leverage of virtually all the Arduino-compatible serial transceivers like RS485, radio or infrared modules, still having PJON unchanged on top. Analog sampling. Analog sampling is designed to sample digital data using analog readings and can be used to communicate wirelessly through any sort of radiation transducer. It works nominally with a single pin for bidirectional transceivers or using separate pins for transmission and reception. The most basic example is to connect 2 devices using a couple of visible light LEDs, used as wireless transceivers, wired to the A0 pin. Leveraging the duality of LEDs. Ability to emit photons if electrons are traveling through the LED junction. Ability to emit electrons if photons are hitting the LED junction. It is possible to use them as wireless bidirectional transceivers. Analog sampling can be used to experiment with short-range infrared or visible light communication, medium range using lighting to stream communication, or long-range laser communication.